All right, what do we got here? We have nothing right now because my projector seems to be unstable. There we go. We have 3.1, the beginning of polynomials. And I want to do the most interesting question first, because why not? Which happens to be the last question on this homework assignment. It's about Alberto. He's designing a container in the shape of a rectangular prism, which is a word you learned in 6th grade. Rectangular prism is just a box. This one is closed. Not that it matters, but it's a rectangular prism. And the text tells us the length of the container is 10 inches longer than the height. So if I call the height x, the length has to be x plus 10. The text also tells us that the sum of the length, width, and height is 25 inches. Because I have the height and I have the length and I need the width. So the length is x plus 10, the height is x, and I don't know the width, but I know if I add them all together I get 25. See? Perfect. Now I'm going to put those three things together. Looks like I have 2x plus 10 plus w is 25. And I want an expression for the width, so I'm going to take away 2x and 10. So the width is negative 2x plus 15. All right. Which, that work was supposed to go there, wasn't it? Sorry, I jumped ahead of myself. Write a formula for the volume as an expression of x. So the volume as a function of x is where you take the length, the width, and the height, and you multiply them together because it's a prism. You'd know that if you took geometry, or heck, it used to be a middle school standard. Anyways, length, width, height, x plus 10, width is negative 2x plus 15, and then the height is x. I'm going to put that x out front. All right, write your equation in standard form. This is a factored form. Factored forms are useful for finding domain. I can tell you right now x can't be 0 because if it was 0, you'd have a volume of 0. Plain and simple. Now, if that makes sense or not, whatever. All right, so write your equation from 2 in standard form. So here's what we're going to do. There's lots of ways of doing this. What I'm going to do is I'm going to focus on this first. You do it however you want to do it. I'm going to do it this way. What do I know? X times a negative 2x is negative 2x squared. X times a 15 is plus 15x. 10 times a negative 2x is minus 20x. And 10 times 15 is plus 150. And before I distribute that x, I'm going to combine like terms. I have a negative 2x squared minus 5x plus 150. And the next thing is to just distribute this x to all three pieces. So volume as a function of x is a negative 2x cubed minus 5x squared plus 150x. Graph your equation, state its domain. So we're going to kind of cheat a little bit here. You could either graph this one or you could graph the previous one, doesn't matter. If you still haven't gotten a TI-84, one kid told me, he's like, I'll lose it. I ain't paying them any money. Okay. See you next year. You need a TI-84, kids. Zoom 6. What a funky looking graph. It's got some weird intercepts too. The intercepts make sense. You've got an intercept back here at -10. See it? If x plus 10, x is -10. You should have an intercept right here of around 7.5, which you do. And you really can't see much of the rest of the graph, but there's also an intercept at 0. We're going to look out a little bit. I'll change the x-min to -15. The x-max I'm going to leave alone. I'm going to look up about 80 units and see what I see. Nope, I don't see it. Nope, I want to see it where it maxes out. Go up to 200. Still hadn't seen it maxed. 400. There we go. So the full graph is somewhere up here close to 400. And you can see that it's, by the way, this is, we had this lesson today, that is a negative x to the odd. And it is doing what it's supposed to be doing. It's starting high and ending low. That's what she's doing. But she starts high. She crosses, what is it, 4, 5, 6, 7, 8, 9, 10. She starts high, crosses at -10, does some stuff, comes back up, hits 0, rises to almost 400, and then falls and crosses the x-axis at 7.5. So this was -10, 0, 0, 0, and this was 0, 7.5. That's what your graph looks like. State its domain. The only thing that makes sense is this area. These are the only volumes that make sense. Because there where volume is positive and there is where the x value is also positive. You can't have negative lengths. So this is the only volumes that make sense. And they happen between x values of 0 and 7.5. There's your interval. This is, by the way, an interval. If you like your set builder notation, you'd say 0 less than x less than 7.5. Something like that. Interpret the x-intercepts. The x-intercepts are where we have no volume. There is 0 volume because there is no prism. Plain and simple. Heck, this one doesn't make a lick of sense. That's saying that you have a length of you have a height of -10. If you have a height of -10, then you would have a width or a length of 0. Doesn't make any sense. What dimensions maximizes volume? That's going to be right up here. That's at that relative maximum. That is between 0 and 7.5. So I'm going to fire up my T84. I'm going to hit second trace. I'm going to scroll down to 4 for maximum. And I'm just going to look for my cursor. Notice I'm holding that down arrow. I get close to the top, I press enter. I go a little bit to the right, I press enter. I press enter for a guess. And there she is. The relative maximum is 393.66 cubic inches. And it happens when x is about 4.24 inches. I'm going to use the approximation symbol, so I'm rounding. And that's 12, which was by far the most interesting problem on that homework set. I'll be right back. All right, here's the front. I know you guys need to see 3, but you also need to sit down and figure it out. cubic function behaves like this. That's what a cubic looks like. But it can also be something like this. The point is, starts low, finishes high. So you can figure it out from there. But you're going to have to draw something. Or don't. I'm not going to do both of these. I'm just going to do one of them. For the function f of x is x cubed minus 2x squared plus x plus 1, find the average rate of change. Your formula for average rate of change is f of b minus f of a, sitting pretty over b minus a. And here's where you get a, and here's where you get b. So you plug these things in, that's all you do. F of b happens when you plug in a 2. It would be a 2 cubed minus 2 times 2 squared plus 2 plus 1. And I'm going to use a storage feature here because I'm going to plug something in twice. I'm going to take a 2 and I'm going to store it to x. Then I'm going to type in the equation. The equation was 2x cubed. Sorry, the equation was x cubed minus 2x squared plus x plus 1. It's a 3. Here's why I'm using the storage feature. Because now I don't have to retype everything. Although this one's pretty easy. If you plug in a 0, you're going to get, what, 1? But not everybody sees that. I've got kids who can't add. There's a lot of juniors who just can't add. If I had more energy, I'd probably rant about that, but I'm pretty tired. Now what I did is I took a 0, I stored it to x, and then I just arrowed up and highlighted what I typed in previous. Pressed enter again. It's 1. So now I can plug everything in. F of b was 3. F of a was 1, so take away 1 over 2 minus 0. And I get 2 over 2, which is 1. I'd say half of you guys could do average rate of change on the last basics quiz I gave you. You'll probably be fair on that. It's not too hard. All right, write each polynomial in standard form. For each function, find the degree, number of terms, leading coefficient, sketch a graph of its end behavior. One of y'all gonna be like, I don't understand. Whatever. This is as easy as it gets. If you don't understand this, you're in trouble. Standard form would put the highest exponent first. I don't know why I've got that there. That's the biggest thing. It's negative x to the 4th minus x cubed plus 5x squared plus 9x and then plus 12. Notice what the exponents are doing. They're dropping. This would be to the 1st. That'd be to the 0th. No, it'd be x to the 0th. But there's a descending order in exponents. Anyways, the degree here, this is a 4th degree, also known as a quartic. The number of terms, what do we got? 5. I just counted 1, 2, 3, 4, 5. The leading coefficient is what's in front of x to the 4th. It's a negative 1. And you're supposed to sketch a graph of its end behavior. The end behavior is determined by negative x to the 4th. If you just go look at your notes, you'll see like negative x to the n is even. It'll tell you it starts low, ends low. That's what it does, I swear. All right, we got to graph the function problem, and I need to take another break. I've been up for quite a bit already today, and I'm wearing out. Be right back. All right, I'm at the graph the function. I literally went to y equals on my TI-84. And I'm going to do a zoom 6. I'm going to look at the window. I'm going to play with the window. And I'm going to pick out some nice stuff on it. So it looks like I need to look up a little bit. Let's see if 15 does the job. little more. Maybe 20. Yeah, 20 does the job. I'm going to look down too. Say negative 30. Oh, gotta go farther. Negative 50. Nope, no more. Kind of just sitting here doing guessing check, kids. Negative 70 doesn't. Oh, no, there's still more. You know what? I'm tired of messing with you. Negative 110. Negative 130. There we go. Now I got something. It says I better see a table. So I'm going to hit second table. There we go. I got some nice points here. Now I want you to notice that on your graph there's some stuff back here. Looks like the graph is really interesting up till about negative 4. Then it just shoots off. Negative 5, negative 4. Something's going on around negative 3. We're turning. We go from negative 64 to negative 42. Negative 1, 0, 1, 2. Something happens around 4 to 5. Because we are turning there. There's called a turning point there. But I'm literally just getting my table from the calculator. Anyways, here's your little table. I'm not too terribly worried about the scale of this thing. The big thing is your y-intercepts are right. You got a y-intercept of 20. You cross the x-axis at negative 4, negative 1, and 5. And you got some negative territory down there, and it's huge. We'll just put like negative 100 down here. Anyways, the gist of it is we come in from positive infinity, we fall somewhere around negative 3, we start going back up, fall pretty quick, and then we start going back up, come through here. I missed one, there's one right there, there's 1, 0. Fall, turn, and rise. A lot of times you'll find, oh, this is number 8, goes here, okay? A lot of times you'll find that, I don't remember what I was going to say. Anyways, better see a table, identify and label the x-intercept, the y-intercept, the relative maxima, and the relative minima. So your x-intercept you have on here, she's at negative 4, 0. You have one at negative 1, 0. You have a y-intercept at 0, 20. You have another x-intercept at 1, 0. You have another x-intercept at 5, 0. There's your very important points. This is a relative maxima. These two guys are relative minima. They're important points. And I'm going to find that by hitting second trace 3, which is a minimum function. I'm going to get left of it, I'm going to press enter. I'm going to get right of it, I'm going to press enter. I'm going to press enter for yes. And it looks like it's around negative 2.9, negative 64.4. I don't have enough room to go with a lot of decimals here. There's a relative minimum. There's another one to the right. And again, this is all supposed to be in space 8. I'm tired. Get left, enter, get right, enter, enter for a guess. It's at about 3.6 and about 127.3. That is a negative 127.3. All right, that was number 8, and I put it in the wrong spot. And I'll be right back in a minute to do number 9. And I'll probably stop on 9. Number 9 is a rough problem. You're not going to find a lot of people in this world who could probably do number 9. It's just a rough problem. Use the information below to sketch a graph of the polynomial. It is positive on the intervals, these intervals, and negative on these intervals. What's going on here, and that should be a negative 3, by the way, is when you change from positive to negative, you cross the x-axis. So what these two things are really telling me is it's telling me where I have x-intercepts. There are x-intercepts at positive from negative infinity to negative 3, x equals negative 3, x equals negative 2, 2, and 3. 1, 2, 3, 4. Must be a 4th degree polynomial. Nope, I forgot the 0. There we go. Must be a 5th degree polynomial. Sorry. I need to be more. She's negative between negative 3 and negative 2. So between negative 3 and negative 2, I am underneath the x-axis. So something's going on here, okay? I am negative between 0 and 2, so again, something's going on here. And I am negative from 3 to infinity, so the graph is literally dropping like a rock there. Positive from negative infinity to negative 3, so it's coming in from up high. 0 to 2, sorry, negative 2 to 0, positive, and 2 to 3, positive. And let's see if everything else works out. Decreasing from negative infinity to negative 2.67, yeah, it's going downhill. From negative 1 to 1, yeah, it's downhill. From around 2.5 to infinity, also true, downhill. So that's what the graph looks like. If you're curious, it's probably a 5th degree polynomial. It has 5 x-intercepts. It is at least, if I can write, x to the 5th. And since it starts high and ends low, I know it's got to be a negative x to the 5th. Because if it was positive, it would do this. Anyways, not that you care. Yeah, I'm done with that. That is your 3.1 Envision homework. It's actually not too bad. I did pretty much all the hard ones. You're welcome.